Then we'll take a look here at rational expressions and just reducing to lowest terms before we get into dividing polynomials. So I like to write these as a product of primes. Like 7 is already a prime number, 5 is already a prime number, but we can break up our 10 into 5 and 2, right? And we can break up our 49 into 7 and 7. And then we can start canceling stuff. 7 over 7 cancels. 5 over 5 cancels. And so this just simplifies to 2 sevenths, right? Now for dividing, right, you remember the old keep, change, flip, right? You keep that, you change it, and you flip it, right? But we'll do it vertically. So what you're doing is you're multiplying by 14/5. If you do it at the bottom, you got to do it at the top there. So that cancels. See, it just leaves you with 1 on the bottom, right? It's like 7 over 1 is just 7, right? That's why you multiply by the reciprocal, top and bottom. So we're just left with keep, change, and we flip this 14 over 5. So then it's just a matter of canceling. 5 over 5 cancels, so we're left with 14 over 2. Well, 14 over 2, of course, is 7. Let's do another one vertically. Multiply by the reciprocal. If I do it at the bottom, I got to do it at the top, right? Because 9/25 over 9/25 is like 3 over 3. I'm just multiplying this thing by 1, right? So then that'll cancel and leave us with just a 1 on the bottom. So now we're left with 5/3 times 9 over 25. And we're like, well, 9 over 3 is 3 over 1, and then 5 over 25 is 1/5. So we got 1 times 3 over 1 times 5. So it looks like this just ends up being 3/5 on that. So that's with numbers. Now let's go ahead and factor with some rational expressions, right? So we've got a variable involved here in our numerator. So let's go ahead and what can we factor out of 5x and 20? Let's take 5 out, right? And now we've just got the 5 over 10. Well, 5 over 10 is 1/2. So we got 1 times x minus 4, which is just x minus 4 all over 2, right? Same as x minus 4 all over 2. All right, why don't you guys go ahead and try that one right there. Good question. Yes. Yes, so 2 is a common denominator of the x minus 4, so you can put it as x over 2 minus 4 over 2, you bet. So this is the exact same thing. 4, right? Yep, same thing. Bottom one would be x over 4 plus 3 over 4. Yeah. Yep, so let's go ahead and reduce it here. What are we going to take out of the top? X, good. So we got, what are we going to take out of the bottom? We're left with now notice both of those have a factor x minus 12, so x minus 12 over x minus 12 cancels. So this just ends up being x over 4. Let me have you guys try that one right there. Make sure you got the same thing there. And move on to that lower one there. So let's simplify 9x plus 63 over x squared minus 49. Again, we get factor, right? So we can take a 9 out. Then we got difference of squares on the bottom. So notice our x plus 7's cancel. So we're just left with let you guys try this again. Let's see the difference of squares on the bottom there. You're taking a 3 out of the top at each of those terms, right? So you get 3 over x plus 12. All right, let's keep going with some more of these. So at the top, I like to do the old backwards FOIL, x squared plus 6x minus 16. So I'm looking at the factors of 16, right? What will this factor into? Yeah, each one of them, you bet. What's the other one got to be then? Yeah. So it's got to be minus 2, exactly. Yep. And check it, right? FOIL it back. X squared minus 2x plus 8x minus 16. Oh, yeah, that's the x squared plus 6x minus 16. So it works. And then you can factor. If you want, you can throw the parentheses on that because you're canceling that entire binomial x plus 8 there. So you're just left with x minus 2. That one. All right. This is another you try it. I'm going to pause it. All right, go ahead, check yourself. Get that x minus 12 there. So the top factors into x minus 12, x plus 2. Let's do this next one. We got x plus 7 times x minus 3. Now, notice on the bottom, I don't have anything cancels right now because I have 3 minus x, not x minus 3. So what I could do, though, is I'm looking at my denominator, and I'm like, gosh, can I manipulate that? What could I take out of 3 minus x? Negative, yeah. If I take a negative out, negative 1 out, or negative 1, I'm just going to put it as a negative, right? What would I be left with? Negative 3 plus x. Let me write it another way. Right? And we can take that negative up top and notice those cancel. And that negative 1, we'll just take that up top, right? So we got a negative x plus 7 or negative x minus 7. Either one is fine on that. Let me have you guys try that one right there. Go ahead, check yourself on that one. End up with negative quantity x plus 9 or negative x minus 9. Same thing on that. Okay. All right, now we're going to factor backwards FOIL top and the bottom on this one. So we got x minus 10, x plus 3. Looks like this one will end up being, let's see, 218 doesn't work, 9 and 4 doesn't work, 3 and 12 works. There we go. 3, 12, it's got to be plus plus or minus minus. It ends up being plus plus. Again, make sure you check yourself. Check, 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 check. FOIL is back. And then you say what cancels. Looks like just those cancel. Let me let you guys try this one. And go ahead and check yourself on that. Oops. All right, let's go this one now. So we'll go to difference of squares. So we got y minus 9, y plus 9. Notice on the bottom I can take a 2 out of everything before I do this. Now I want to factor that y squared minus 7y minus 18, which will factor into y plus 2, y minus 9. And then you notice those will cancel. So you're left with y plus 9 over 2, y plus 2.
It doesn't matter if we have to go back to 2y plus 4 for when we put our x.
Yeah, it'll accept either one. Yep. Yeah, so you can just leave it right there. Have you guys try this one. Go ahead, check yourself there. Y plus 6 over 7, 20, y plus 1. Then let's move to that one below. Factor x squared plus 2x plus 1. The denominator, I can take an x out of each of those, and I'd have 1 minus x squared. Now, 1 minus x squared is kind of awkward, so I'm going to take, because I'm looking at x plus 1, x minus 1, so I'm thinking, gosh, that is difference of squares, but let me take a negative out. So let me take a negative 1 out. So I took a negative 1, put that in front of that x out there, and that'll change this sign and that sign. So then I have x squared minus 1, which is difference of squares. Oops, I changed this. I'm sorry, guys. That's supposed to be x plus 1, x plus 1. Difference of squares, x squared minus 1. That factors into x minus 1, x plus 1. And then I can get some stuff to cancel. So I'm left with x plus 1 over negative x. And I'm going to go ahead and take that negative up top. Negative goes up top. And we can stop right there. Or you can write it as negative x minus 1. Either one. All over x. Yeah. Oh, I made an error. Did you guys see it? What'd I forget? Yeah, the x minus 1. Sorry about that. Oops, a daisy. I still have that. See, that didn't cancel, did it? All right, let's keep going here. A few more of these, and then we'll move into finding values. So x squared plus 14, x plus 49. So go ahead and factor that. Bottom, I'm going to factor out an x, and I'm left with 49 minus x squared. I'm going to take a negative x out, so it'll change those to x squared minus 49. So it looks like one of these x plus minus 7s. Oh my gosh. Change that again. That is supposed to still stay a plus right there. Okay, now we can cancel x plus 7, x plus 7. I'm going to take that negative up top as well. So let's take that up top. And now we're all done right there. Now this one is one of those where you want to think about, like, it's quadratic in form. If u is x minus 7, this is a lot like 3u squared plus 20u plus 12 over 2u squared plus 5u minus 42. And then I would factor it in that form, and then I would plug the x minus 7 back in. That's how I would do this one if I was you guys. All right. So this will factor. So I'm like, well, it's a 3u and a u. Down here I have a 2u and a u, and then I'm factoring. I'm like, oh, let me try factors of 12. I try like 2 and 6, and then I check it. 3u squared, 18u plus 2u. There's the 20u in the middle plus 12, right? And then I go ahead and do similarly with the 2u and the u. Try factors of 42. And I foil that back, make sure that works. 2u squared plus 12u minus 7u. There's that 5u in the middle minus 42. So that works. And then notice the u plus 6's cancel. So we're left with 3u plus 2 over 2u minus 7. But remember, what was our u? Yeah, our u is x minus 7. So I've got 3 parentheses, 2 parentheses u. And we're going to plug that x minus 7 in. All right, I'll give you a minute on this next one to kind of try this one. All right, guys, go ahead and check yourself. And we'll get into evaluating some rational expressions here. All right, so for example, if we're given a rational expression, x squared minus 16x plus 16 over x squared minus 64, and they say it's evaluated for x equals 2, we're just going to throw in the 2, right? All we do, throw the 2 in, see what you get. Throw the 2 in for x. You guys mind if I shrink that a little bit? So I got x is 2, x is 2, x is 2. So we've got 4 minus 32 plus 16 over 4 minus 64. Looks like we end up with 1/5 on that one. And the issue is plugging that in. Okay, go ahead and try that for this one. Check yourself on that, and then let's get into a little bit of domain for rational expressions. So with rational expressions, remember we cannot divide by 0. So if you want a little more explanation for that, definitely take a calculus course, but we cannot divide by 0. And we'll look at some functions in this course, like 1 over x, and how they behave and stuff. But we definitely cannot divide by 0. It's undefined. That's what you want to remember anytime you've got these kind of rational functions is you take a look at it and you say, well, the only issues are going to be when anytime the denominator is 0, right? So my x cubed minus x, this cannot be 0, right? And let's go ahead and find the zeros for that. Remember, that can't be 0, so we go ahead and we factor it all the way. Now this can be 0. So in other words, x can't be 0, x minus 1 can't be 0, and x plus 1 can't be 0. So it can't be 0, can't be 1, can't be -1. Any of those three, if I plugged it back into the original function, will give me a 0 on the bottom, right? My denominator. So it's undefined there. So when you state your domain, you say the domain is x such that it's all real numbers except for -1, 0, and 1. Can't be any of those. Or if you want to say it the other way, you go from -infinity up to -1. Don't include it. Take off from -1 up to 0. Don't include 0. Take off from 0 up to 1. Don't include 1. And then take off again after 1. Right? So it'll have all those breaks at -1, 0, and 1. Right? The domain of that rational function. Okay? Go ahead and do this last one together. Again, the domain rational function, this 2x minus 2x cubed, remember that cannot be 0. So let's factor out. I'm going to factor out a -2x, so it'll change those inside. Oops. So x cannot, oh sorry guys. X cannot be 0, x cannot be 1, x cannot be -1, right? So my domain is all reals except for, in this case, the same ones, -1, 0, and 1. All right, thanks for listening, you guys. See you next time.